we understand, right? We understand that statistics, you use it, right, when you want to present data as a way of supporting the information that you have when it comes to decision-making processes, right? So let's look at the types of statistics, right? Because which is very important. It is very important for this module, and it's also very important for some of you that are going to do dissertations and theses, right? Some of you are going to do what is called quantitative methods when it comes to dissertation. So you need to understand the types of statistics, because for you to use a statistical method, you need to understand, is it descriptive statistics or is it what they call inferential statistics? So the first type of statistics, that the more general one, is called descriptive statistics. So basically, when you're talking about descriptive statistics, we're talking about summarizing and describing data, right? So when you are summarizing the data and describing it, you make use of what is called frequencies, percentages, measures of central tendency, measures of dispersion, right? Or sometimes you can look at the shape of distribution. Maybe you've heard what is called like the normal distribution curve, right? So you're just that's all statistical terminology. Then there's this other type of statistics called inferential statistics. So you use it when you want to infer or to make generalization about a population, right? Maybe you want to find I'm trying to look for an example, right? Maybe, for example, how COVID-19 has affected gender-based violence, right, in South Africa. So you can't go and ask each and every person in South Africa that is a victim of gender-based violence, right? So what you do is you look for a certain section, right, a geographical area, and then you take a sample. But the result that you get from that sample, you infer it or you generalize it about the population that is within South Africa. So that's where inferential statistics comes into play. Now, this type of statistics, like I said, it comes into play when you do your dissertations. But in this module, we are not going to delve deeper into inferential. We are only going to talk about descriptive statistics. All right, so we can't talk of statistics without talking of what is called data presentation. Because remember, we are saying that statistic, it is a tool that you are using, right, to support your decision. So it's a way that you are using to present data that will support the decision that you are making, right? So we can't talk of statistics and not talk about data presentation. So when you're talking about data presentation, we know that information obtained from a statistical analysis is meaningful to business managers only when it can be interpreted and communicated effectively and concisely. So if you are not able to communicate, right, whatever information that you got from a statistical analysis, and if you are not able, right, to interpret, then it's of no use, right? So you must be able to interpret and you must be able to communicate that information. So there's a certain way, right, that you can communicate that information, right? So one way that you can communicate statistical information is through the use of what we call summary tables and charts, right? So we use tables and charts to convey information more vividly and quickly than a written report, right? So you might have two options, right, of presenting information as a written format, or you can present information in form of tables and charts, which depends with the type of statistical information that you have at that particular time. So the good thing about using tables and charts is the information is conveyed more vividly and quickly than when you just present information in a written format. Let me give you an example, right? So let's look at this slide, right? The beauty of using tables. So you can see that on the left side, right? Or this left side here, you can see that this is information that is being conveyed to a certain audience, right? But this information, you can see that it is in written format. There's information that is being conveyed in that written format, but you see, by looking at the information, you can't really tell what type of information are we supposed to get, right, from this information, right? So it means that you have to read. So sometimes, like in this case, this paragraph might be too long, right, for a person to really read and then understand what the type of information that they're supposed to glean from that written format. But you can now find that the same information is now being conveyed through a use of a summary table, which is now more vividly, right? We can actually try to understand what this type of information is without anyone even interpreting to us, right? We can see that this is a table, it has institutions, right? It has the rank of that institution and maybe the number of students that are enrolled, right? So you can see that this is the same information, but it's conveyed in two different ways. So that's the beauty now of using charts and tables, because tables, they convey information more vividly, right? So that's one of the reasons why summary tables and charts, they are used in statistics, because it conveys information more clearly, right? Then let's talk about what is called a frequency table. So basically the chapters that are the previous slides, they're covering unit 1 and unit 2. If you go and check your study module, unit 1 and unit 2, it's only talking about the theory part, right? It's theory part. I think in an examination, I think it only covers if it is like I think it might be maybe 5% of your exam, right? It's just theory, the theory part. So basically that's what I was just trying to give an overview of, but I didn't manage to cover a lot. Like I said, it covers 5%, right, of your module. So let's now start where most of the information. So now this slide, right, it's starting to give an overview of unit 3 going forward, right? So let's talk of what is called a frequency table. So a frequency table is a form of table that is employed, right, in statistics. So basically, when we create what is called a frequency table, what we are doing basically is we are just showing the number of occurrences of a variable, of a factor, which is falling into a specific range or category. Okay, that might look as if it's a lot of information to process, right? Let me give an example, right, of how to create a frequency table. So let's look at a group of 47 males, right, of various ages. So 12 are between 20 to 29, 13 are between 30 to 39, 7 are between 40 to 49, 8 are between 50 to 59, and then the remaining are within 62 to 69. So what we do now we want to group this data based on specific ranges in specific categories. That's the reason why when we create this frequency table, so a frequency table has at least 2 columns. It has at least 2, because there might be more. I think the next slide will show you when it will have more columns. So it has at least 2. So the first 2 will be the interval, what we call the class, right? The intervals or the class interval, and then the other one is what we call the frequency, right? It's called the frequency table, right? The frequency. So I'll explain what the frequency is in a moment. So the intervals, now what you do is you divide the years, right? Like in this case, we are interested about the number of nails that falls in a specific range of years, right? So you create what is called an interval. In this case, they had already created it for us, right? So 20 to 29, that's our first category. Then 30 to 39, that's the second, and so forth. So we come to find out that out of a group of 47 males, 12 have got ages that lie within the range of 20 to 29. That's why it's written 12 there. So the frequency of the interval 20 to 29 is what? Is 12. That's what frequency is all about, right? So there are 13 males that lie within what? 30 to 39, 7, between 40 to 49, 8, between 50 to 59. So in other words, when you create a frequency table, what you are doing is you are grouping data. right? You are just grouping data. That's what you do, right? You are grouping data based on specific range and specific category. That's why it says that the frequency table shows the number of occurrences of a variable, right? In this case, we're interested about, right, people that have ages between 20 to 29. Then we come to find how many people within our sample, within our target population, right? Whatever our data set, right? How many people lie within that type of category. So that's how you create what is called a frequency table, right? Then now, from this table, you can deduce that the majority of males are young. How did we come to see that, right? Because you can see, because we have already grouped, right? So it's easy to see that the definition of person being young is their age must be below 40, right? So you can see that everyone that is below 40, which includes this first category, right? So it means that the majority of the males are young, and then most lie between 30 to 39. Why? Because that's the highest frequency. So this interval of years is the highest frequency. So basically, a lot of people, they've got ages that lie between 30 to 39. Then if we add all these frequencies, they must give you a total of 47, which is the total number of the data set that we had, the total values of data points that we had initially when we started the research. So let's talk of what is called a cumulative frequency table, right? So this is very, very, very critical, because for now it might look as if I'm explaining something that might not be useful at this particular moment. But you come to find out that when we go now to calculate the measures of central tendencies, this cumulative frequency table, right, will come in handy. So you need to understand, just make sure that you really, really understand this foundation that I'm laying, because it will be of great use when we start to do the calculations themselves. So let's look at another example to explain how you come up with what is called a cumulative frequency table, right? So let's consider a class consisting of 100 students. Suppose the teacher gives the entire class a statistics test, which has a maximum mark of 100. So upon marking the script, which are in no order whatsoever. So these scripts were not in a particular order. They were not grouped, right? He was just marking them randomly as they were submitted. So he puts the marks into a table as shown below. This represents raw data since there is no set order of marks. So basically, this is just a rough table, maybe just a recording table, right? Just to record each and every mark that the student had for the test that they wrote, right? So now this is the cumulative frequency table now. So what you need to understand is, we know that the lowest mark that a person can get is what? The lowest mark that a person can get is 0. And then the highest possible mark that a person can get is what? Is 100. So basically, it depends. Now, when you're creating a cumulative frequency table, if they don't give you the class intervals themselves, you can just use your intuition, right? Maybe you can use 0 to 9, or you can use 0 to 19, depending with how you feel comfortable in creating the intervals. But in this case, they gave us these intervals, right? So there are three things that I want you to take note of, right? I need your undivided attention in this, because it's very, 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 very critical. So there are 3 terms that I want you to understand, to know, right? There's what we call an upper class limit for each and every class. Remember, each and every interval, right? These intervals, right? Class intervals. So there's what we call upper class limit, and then there's what we call lower class limit, and then there's what we call class width, right? So let me start with what is called an upper class limit. So each and every class interval, it has what is called an upper class limit of that particular class interval. Right. Let me give you an example. In this case, let's take the first class, right? The first class interval, it is 0 to 9. So 9 is the upper class limit of that particular class. So 9 is the UCL, And then for the second class, right, you can see that the highest, right, limit for that particular class is what? Is 19. So the highest value for that particular class, that is what is called the upper class limit. Then the LCL now, that's the lower class limit. In this case, in first instance, there is 0 is the lower class limit, and then 10 is the lower class limit for the next one, for the next class interval. Now, class width, there's what now they call a class width. Now, when you are just looking, right, when you are just looking, you would think that the class limit here, the class width is 9, because if you just say, Mara, starting from 0 to 9, 9 minus 0 is what? It's 9, right? But that's not it. That's not it. If you come to find out, the class width actually here is not 9. The class width is actually 10, right? Because if you count your fingers, right, starting from 0 as your first finger, right, you come to find out that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 will fall on the 10th finger, right? But now you can't do it maybe if the class interval is too big. In this case, I could count my fingers because it's 10, right? I knew that I could count. But there are some instances where you are given class intervals that are so big that you can't even count on your finger. So how do you determine class width? Because calculating the class width is very, very, very critical, because we are going to calculate what is called a median and mode for grouped data later on. You need to know how to calculate the class width. That's why I'm saying I need your undivided attention in this, because if I fail to lay the proper foundation now for this, then it means when we get to that part, a lot of people are not going to understand where we are going to get the class width. So there is a particular way for you to calculate the class width, right? So you can either use upper class limits only and use lower class limits only. So let's start with upper class limits only as a way of calculating the class width. So what you do is you need to identify two adjacent classes, right? You can't just take two abrupt classes, right? They must be adjacent. They must be one after the other, right? Like in this case, let's take the first one and the second one. So if we are using upper class limits as a way of calculating the class width, what we need to do is we say that this upper class limit of the second class, if it subtracts the upper class limit of the previous class, right? If we say 19 minus 9, right? So in this case, we say 19 minus what? Minus 9. It gives us what? It gives us 10, right? That is to prove to you that the class width actually was 10 and not 9, right? Because if you just say maybe class width, you just say upper class limit minus lower class limit, that's wrong. You get a wrong class width, right? The two ways for you to calculate the class width is the first one, to use upper class limits, which is the one that I'm explaining now. Or we can just take maybe these two classes, right? 69 minus 59, you still get 10. So if you are using upper class limit as a way of determining your class width, you need to take upper class limits of two adjacent classes that are coming one after the other, which is the same thing again if you are to take lower class limit. So it's either you use upper class limit or you can take lower class limits. You can't mix. You can't say you take upper class limit and a lower class limit. You get a wrong answer. Like in this case, if you say 19 minus 0, you get a wrong answer. So it has to be upper class limits only, or it has to be lower class limits only. So upper class limits, I explained that. Now let me come to lower class limits. So taking these first two classes, 10 minus 0 is what? It gives us 10 again, right? Or if we come and we take 40 minus 30, it gives us 10. So it doesn't matter whether you use lower class limits and upper class limits, as long as you are consistent, right? You will get the same answer. So that is how you come up with what? With the class width, right? Now, frequency, like I said, that is like in this case, you come to find out that how many students got a mark from 0 to 9. You see that it is 1. How many students got marks from 10 to 19 is 2. That is how you come up with the frequency. You're trying to group, right, the people based in the specific category of marks that they lie under. right? That's the whole point of frequency, right? How many times does, right, a certain variable, number of occurrence of a certain variable fall in a specific category, right? Right, or a specific range. That's basically what frequency is all about. But now we want to talk about what is called the cumulative frequency, because again, cumulative frequency, which is denoted as capital letter F, right? Frequency is small letter f when it comes to frequency table, but capital letter F, you're talking about cumulative frequency, which is now it also plays part when it comes to calculating, going ahead of myself, calculating the mode and the median later on, right? So that's why I said I really wanted you guys to really understand what I'm trying to explain now. So now let's try to understand, how do we calculate the cumulative frequency given the frequency and the class intervals. So what you need to do is for the first frequency, that's the same cumulative frequency. That's why there is a 1 there. But from there now, there's a certain method that they employ, right, for you to calculate the cumulative frequency. So it goes like this. So you have the first cumulative frequency, right? So what you do is you say cumulative frequency of the previous class. We want to calculate the cumulative frequency for this class, right? So you say cumulative frequency of the previous class plus the frequency of that particular class, which is 1 plus 2, it gives you what? It gives you 3. Now, when we want to calculate cumulative frequency for this class, we say cumulative frequency of the previous class, which we calculated as 3, plus the frequency of that class, it gives you what? It gives you 8, which is the same again for this class here, right? We say cumulative frequency of the previous class, which is 8, and then the frequency of that class, which is 6, which gives us 14. So you do that so on up until you get to the final class, which must give you a total number of the sample or the data values that are within your whatever your sample and everything, right? So now, but the good part of this course is you won't do it manually, right? I'm going later on when we start to do the calculations themselves. I'm going to show you how you use Excel, right? As long as you've got these two, you have made a column for intervals and you've made a column for frequency table. Excel can do automatic calculations for you for the cumulative frequency. I think some of you that are well acquainted with Excel, you know that Excel, it just needs a formula from you. When you use a formula, it can calculate the rest for you. So for now, just understand the fundamentals of how you calculate the cumulative frequency, but the process, the rigorous process of you doing the calculations themselves, you're not going to be the one who does that. Excel is going to be that's where Excel is going to come in handy. So now now we have talked about tables, right? That's the table that we're going to meet, right, in this course. Then let's talk about what is called graphs and charts, right? So a table is a useful way to present the detailed data, but a picture or a diagram is more powerful if we want to focus attention on a particular aspect, such as a dominant feature or a trend. So there are some instances where you want to check whether the data that you have, right, is it following a certain trend, right? Is there a dominant feature, right? So a table can show you that. Maybe the shape of a graph or the shape of your data. Maybe you're interested to know whether if data follows what is called normal distribution curve, right? You can't actually tell from a tabular form of data, right? Right, because it's just, you can just see that the numbers are fluctuating, but you can't tell the trend itself. So that's where graphs comes into play when you want to see a certain trend of future. So let's look at this example, right? Where you are given that a company, it was operating for this particular years, right? Then you are given the profits that the company had. So from the table, you can't tell actually the trend, right? But when you plot a graph, then you can see that for those number of years, the company have been operating at a loss. right? It has been operating at a loss. So that's where graphs comes in handy. That's where charts comes into handy when you want to show a particular trend, right? So a study of the table shows that profits have dropped considerably, and this trend can be better depicted using a line graph. Another type of chart that is also used, I don't think in this course we're going to talk about it, but just good to know, is what we call bar chart. So instead of you drawing what is called a line graph, you can draw that type of graph using bars. So instead of just the distance, right, itself, it will be replaced by what is called a bar, right? So you can still see the trend. The trend, you can still see it, even if you use what? You use bar chart. So there's another type of chart again. Some of you that are going to do dissertations, you're going to employ, you are definitely going to use this. You see, when you collect your data, there's what they call demographic data, right? So you need to show that type of data in form of a pie chart, right? So that's where pie chart comes into play. So pie chart is usually used when proportions are to be depicted relative to a whole. So you want to see the percentage of a certain segment of that data based to the whole amount of that data, right? So in essence, it is a circle divided into segments with the size of each segment proportional to the value of the variable relative to the whole, and is usually expressed in percentage terms. So let's look at an example of a father who gives spending money to each of his 3 sons. The eldest, Josh, gets 120. The second born, Matt, gets 80. And the youngest, David, he gets 50 rand. So now to express now the segment of the amount that Josh got, or each son got, right, as a percentage of the whole amount that the father gave all 3 of them, what you need to do is you have to calculate the total amount where you add 120, 80, and 50, where you get 250, right? Then you express now the amount that Josh got as a fraction of the whole amount, right? So you say he gets 120 out of 250. So you say 120 over 250 by 100, you get 48%, which is this gray part. Then Matt, it's 80 over 250 by 100, which gives you 32%, which is this yellowish part, right? And then finally, the youngest, which is what? Which is David, 50 over 250, right? Which gives you 20%, right? Which is that brown part over there. So now let's look at what is called a histogram, right? So a histogram, it is a graphical display of frequency display. It looks like a bar graph, right? It looks like a bar graph, but it is a special type of a graph, right? Because now when you remember, we said we have what we call, when you group data, right, you create what is called a frequency table, right? So that frequency table, when you have that column written frequency, when you plot those frequencies in form of a bar-like graph, that bar-like graph is called a histogram. So when we have grouped data, you can either display them as a frequency table, or you can display them in form of a histogram. It's still same information that is being conveyed, right? So this is that frequency table of 47 men, right? But now the frequencies are now displayed not as a table, but as a form of a chart, which is called a histogram. So now this part from this, like all those previous slides, I was just giving you a theoretical perspective of some of the terms, right, that we are going to talk about in this course. Now, from this slide onward, I'm now delving into a little bit of calculations, right, so that you can have an overview of how I deliver these lectures, right? So that you can see, right? Like, remember, like I said, this is an introductory lecture. You need to understand, just to see, right, to appreciate how we go about it in this lecture. So now I'm just going to show you, if we are to do calculations, how do we do it in this course? All right, so this is unit 3. Right, measures of central tendencies. That's where the calculations now start to kick in, right? So let's first define what a measure of central tendency is, so it is a single value that attempts to describe a set of data by identifying the central position within set of data. So what it means basically is you are given your data, right? Your data set, right? Then you find a single value that is able to describe the whole of the data. That's basically what measures of central tendencies are. It is a single value that attempts to describe, remember, descriptive statistics, right? Descriptive statistics, they summarize, they describe data. So measures of central tendencies are part of what is called descriptive statistics. Why? Because it is a single value that attempts to describe a set of data by making use of what is called a central position within the set of data. So they will help you to find the middle point of your data set, and they will also help you to find what is called the average or the mean. So the three terms that are going to be used in measures of central tendencies is what we call the mean, the median, and the mode. So these are three different values, and you calculate them differently. So before I proceed, I need also to lay this type of another foundation, right? This is also critical, because if you fail to understand what I'm going to explain in this slide, then it means that chances of you failing to interpret any question based on measures of central tendencies, chances are that you're going to fail it if you don't understand this slide that I am now about to deliver. So what you need to understand is whenever your lecturer is giving you a question that they want you to attempt, right? Questions regarding measures of central tendencies, they'll give you information either as what is called raw data, or they'll give you information as what is called grouped data. So you must be able to differentiate between the type of data that your lecturer will give you, either in an assignment or in an exam. So we need to define what raw data is and what grouped data is. So ungrouped data or raw data, it is the data that you first gather from an experiment or study. So when taking an example of that a test, right, that was written by 100 students. So when the teacher just took the papers and recorded them in a table, that was just raw data. He did not order that data in any way, right? He just collected, he just gathered the data together, right, and recorded the marks. So that type of data is raw. Why? Because raw data is data that is not sorted. As long as data is not sorted, that is raw data. So how do you identify that this type of data is raw? Ungrouped data is data that is given as individual data points or a list. So when you are given that, the first student got 71%, second student got this mark, that type of data which is being given as individual data points, as a list or as individual data points, then that type of data is called raw data, right? Now, grouped data now, it is data that is given in intervals. When you group data based on specific categories, when you group data based on specific ranges, that type of data, you have grouped it together. You have grouped, like in the case of the 47 male, right? We grouped people that have ages 20 to 29 together. We grouped people that had ages from 30 to 39 together. So you are grouping them, right? So that data is no longer given as individual data points, but we have grouped those people together. So this type of data, it is given to you by your lecturer in form of a histogram or a frequency table. So when your lecturer gives you an assignment, if the data is raw, it will be given as individual data points. But if your lecturer gives you grouped data, they will give you a frequency table. So that is how you determine whether the data is grouped or ungrouped. Why did I take time to explain this? The reason why I laid this foundation is the formulas, right, to calculate mean, mode, and median for ungrouped data are different to the methods that are going to be used to calculate mean, mode, and median for grouped data. So if you are not able to differentiate whether data is grouped or ungrouped, the possibility of you using the wrong formula when answering a question, it means that it is high. The probability of you answering that question wrong is very, very, very high if you are not able to differentiate between grouped data and ungrouped data. All right, so now let's start with how to calculate mean for ungrouped or raw data, right? So to calculate mean for ungrouped data, right? This data that is given as individual data points. So you can see here, right, that there is it's an example of marks received for a spelling test for 7 learners. So you can see that the data here is being given as individual data points, right? So what you do now is you use this formula, right? You use this formula to calculate what is called the mean. Mean, in other words, you're just saying you're calculating the average, where you are just saying the sum of all the observations over the number of observations. So basically what it means now is you are going to add each and every data point, right, which is this part here, divided by the number of the data values themselves, right, or the number of observations, right, within that specific sample, right? So in this case, right, we add everything, then you divide by 7, and then you get the mean value of 66.86. So what does this mean? So this value is saying roughly each and every student got 66.86. So you are now describing the whole data, right, but making use of one single value. That's the point of using what is called the measures of central tendency. So now you're just saying, based on the mean, you're just saying roughly, right, every student got 66.86. So now let's look at what is called the median, right? The median. So the median, unlike the mean just gives you an average, but the median now, it is the middle number of an ordered set of data. So this is a key, this is a key point, right? A keyword there. Ordered set of data. It's not just the middle number of any set of data, but it has to be ordered set of data. So it divides an ordered set of data into 2 equal halves. So don't worry, I'm going to make use of an example in the next slide, so that you understand what the importance, right, of why we have to calculate the median in the first place, right? So what it means is 50% of the data values, it means that it lies below that median, and 50% of the data lies above it. So these are the steps that you must take to calculate the median of ungrouped and raw data. So the first thing is, when you are given individual data points, you need to arrange those data points in ascending order. When we are talking about ascending order, we are saying that you arrange them from from the smallest to the highest, right, to the maximum value. So what you do now is, after you arrange them in ascending order, right, what you need to do is you then check whether, right, your data values, the number of the data values, right, if it is odd or if it is even. Because if it is odd, there is a certain formula that you use, right, to calculate the position of that median value. If it is even, again, there's a certain formula which is different that you have to use to calculate the position of the median value. So let's start if maybe if the sample size is odd, right? Like in the previous slide, it was 7 students, right, that wrote a spelling test. So what you need to do is, then we order that set of data in ascending order from the lowest mark to the highest mark. Then what we do is we then say 7, since it is odd, we say 7 plus 1, which is 8, divided by 2, then you get 8, right? Then it means that, divided by 2, sorry, then you get, it's 4. So when you count from the left side, from the lowest, the fourth position, The value on the fourth position is what is called the median value. That is the value that separates your data into two equal halves. But in a case where your sample size is what? Your sample size is even, what you do now is you first identify this n over 2 position. In this case, let's say maybe there were 8 students that wrote, right? So it means our n over 2, it will be 4, which is the fourth position. Then what you do now, when you identify the fourth position, you take the next position, the next highest position. Like in this case, it was fourth position that we identified. Then the next position is fifth. So what you do is you then average the data value in this position with the next consecutive data value. So you take the value on the what? On the fourth position, and you take the value on the fifth position, you find the average, you add the two, you divide the two, the value that you get, right? That is the value that is the median for even data. All right. So what you need to do now, let's look at an example, right? Let's look at an example so that you understand how to calculate the median for ungrouped data. So find the median number of cars. Find the number okay, let me clear the screen here. All right. So find the median number of cars sold per month by a dealer over the past 9 months based on the following monthly sales figures. So these are the values, right, that the researcher takes for the 9 months that they were interested in trying to calculate the value of whatever they were trying to get, right? So the first thing before a person can calculate the median, remember the first rule is you have to order your data in ascending order. This data is not sorted in any way. You can see that this is not even the lowest value, because the third value is score. So you can see that this data is not ordered in any way, right? So what you do now is you order the data in ascending order, starting with the lowest to the highest, right? So what you do now is we are given that it's 9 months. So we will use the first formula when n is odd. So which is n plus 1 divided by 2, which is this part here. So 9 plus 1, it gives you what? 10. And 10 divided by 2, it gives you what? It gives you 5, which is the fifth position. Now, this value is not the value itself. This value that you get is the position in your data, in your ordered set of data. The fifth position is where the median value is. So what it means, after you get that it is the fifth position, you come here, this is the first, second, third, fourth, and this is the fifth, what? The fifth position. So basically what this means is 34. This 34 value, it separates the whole data into two halves. Let's check if this is correct. So values above this value, right? Let's count how many are they. So this is 1, 2, 3, 4. Let's count how many values are below it. 1, 2, 3, 4. So this value, it automatically separates the data into two equal halves, 4 above and 4 below. So how do you interpret this, right? How do you interpret this type of data? So this means that there were 4 months where car sales were below 34 cars per month. So basically now when you're interpreting the median based on this question, you are saying now there are 34 cars, right? Which were, there were 4 months where the car sales were below 34, which is this part here. Okay, let me do this, which is this part here, right? Then there were 4 months where car sales were above 34, which is this part there, right? So basically that is how you use the median, right? To interpret the maybe the question that you would have been given, right? So now let's take for instance where the sample size itself, it is what? It is even, right? The previous slide we discussed when it is an odd value. Now let's see when it is an even value. So it's the same thing, right? Find the median number of cars sold per month by a dealer over the past 10 months based on the following monthly sales figures. So you're given value as individual data points, but it's not sorted. Excuse me. It's not sorted in any way. right? So what you need to do, the first thing is you need to set your what? You need to set your data from the lowest to what? To the highest value. So what you need to do after you do that, you need to find what is called the n/2, right? N/2 position. Here we've got 10 months, which is even. So it's 10/2, which gives us the 5th position, which is this part, right? 1, 2, 3, 4, 5. But this value, as you can see, we can't say that this is the median. Why am I saying so? Because if we count the values of the number of values, right, that are below it, which is 1, 2, 3, 4, right, and then the number of values that is above it, which is 1, 2, 3, 4, 5. You can see that it is uneven. It hasn't divided the data into what? Into equal halves. So what you do is you just mark it as the 5th position. You find the value, which is 27. Then you take now the value on the next consecutive position, right, which is the 6th now, which is 34. What you do now is you say 27 plus 34 divided by 2, then you find a value in the middle of this value, which is 30.5. So basically this value, which is in the middle of these two, definitely divides the data into two separate halves. So you can see that there's a 1, 2, 3, 4, 5 months, right on the left, on the right side, and then there's 1, 2, 3, 4, 5 values on the left. So this value, which is 30.5, which we calculated, it is the median for this value. So how do we interpret now this value, right? So we said this means that there were 5 months where car sales were below 30.5 per month, and 5 months where the car sales were above 30.5 cars per month. So basically, let me do the last slide for you, right? The last slide, which is the mode for ungrouped data. So we can't proceed because the next section is speaking about the mean, mode, and median for grouped data. So that's for another time. So for tonight, before I hand back my time to James, let me explain how you calculate the mode for ungrouped data. So when you are given raw data, which is individual data points, the mode of that type of data, it is the most frequently occurring score, or the number that occurs the most frequently. In simple terms, they're just saying the number that is repeated, the number or the most time, right? So the number that repeats the highest times, that is the mode. In this case, you find that on this type of data that you have been given, 64 is repeated the most times. So 64 is the mode of this type of data. So guys, I'm just hoping that you really enjoyed, and I'm just hoping that whatever that I had prepared, I managed to quite articulate it, and at least now you have an idea how we really go about it in these lectures. Unfortunately, I know you were just listening, but normally what we do is it's an interactive lecture where maybe on a particular slide, maybe that I'll be explaining, if a particular student is not understanding what I'm trying to convey, you don't have to wait for the end of the lecture for you to ask, right? You can just maybe type on the chat, or you can unmute yourself, or you can just raise your hand, and then you can ask whatever question that you have at that particular time, and then I will then explain so that at least you can really understand. So like I said, in terms of asking, you don't have to wait for the end of the lecture. You can just ask at that particular time. It's interactive. You will see, for some of you that are going to embark with me in this type of lecture, you see that it will be interactive. So all right, so I don't know if there is anyone that is a specific question. Just feel free to ask, because remember, this is an introductory lecture, but I was actually covering something that is within your module, right? So just feel free, if you have a specific question, maybe regarding a specific slide, if you want me to come back and maybe try to explain it more clearly, just feel free. You can unmute yourself, or you can you can just type just like what Sean did on the chat there. Okay. All right. So I'm just assuming that maybe this was okay. So I just want to thank you guys for your time. And then I'll just say I'll see you next week. So for those that are going to come in, let me just give James his this platform. Thank you.
Okay. Thank you, Mr. Spanda, for joining us and assisting us with statistical techniques. It's always a pleasure to listen to you lecture on quantitative techniques. Okay, thank you guys for joining in today. I hope you all had a wonderful time, and I would encourage you to continue with us, to join us again next week as we continue into the various units, and also as we go through your assignment and prepare you for the exams. Like I said at the beginning, the cost is 650 for this module to do the lectures, to guide you in terms of the assignment and etc. I'm going to post the video for this lecture in the group, and also I'm going to post a text with just information concerning the lectures and also the banking details. I hope you are all happy, and I hope to see you again next week. Then once you have made the payment, you can just send the proof of payment in the group, or if you don't want to send in the group, you can send to my inbox so that I can record you down for payment for the lecture, so that next week when you join in, you are not left behind. Thank you guys for joining in. I hope you all have a pleasant evening.